Good afternoon, everyone. Thanks for being here at this presentation. My name is Álvaro Sánchez, and I promise you two things. You will learn something new, and you will have fun, so let's try. I'm coming from Madrid, from Spain, specifically from a city called Leganés. I'm telling you this info because who knows this guy? Anyone fan of Utrecht Football Club? Utrecht Football Club signed up this guy who was used to play at Leganés before. I don't know how he's doing at Utrecht, but Leganés, he was terrible, so hopefully he's doing better now. I'm a Java developer. I've been always doing Java, and I'm working on Micronaut at Oracle. The part of Oracle that I'm working for is Oracle Labs. Oracle Labs is a research and development organization within Oracle, and is the home of another project you may have heard of, which is GraalVM. I'm not a developer advocate myself. I'm just a committer on an open source project. But I enjoy going to conferences like this one. And I'm proud that I've been to many conferences and I haven't done any single talk about AI yet. So that's, believe me, that's extremely difficult these days. I'm working on Micronaut since the beginning. Micronaut, let me tell you a story. Micronaut wasn't called Micronaut initially. The code name originally was Particle. But Particle, we couldn't choose that name. There was like a trademark. Domain name was not available. So we ran a poll internally across the team to choose a new name. And I proposed an alternative, which wasn't selected. I still don't know why. My proposal was to name the framework Summer, because we all know that summer is better than spring. So I need to talk to the NLJAG team to make a JSummer conference instead of JSpring. No, that's a joke. I'm literally, believe me, I'm literally a former VMware employee. I have a very good relationship with the Spring team, but that's a different story. So enough about me. Slides are available in the speaker deck if you want to take a picture. And in the meantime, let me ask you a few questions. So who is using Spring/Spring Boot? Raise your hands, please. OK, X is this over there. Thank you very much. No. Who is using Quarkus? OK. Who is using Micronaut? OK. Anyone using anything else that I didn't? What's that? Oh, Jakarta, of course. Yeah. OK. Makes sense. There is another thing that I didn't tell you. I'm a runner. Look at me, believe me, I'm a runner. I run a lot. I run applications, I run containers, and I run them very fast. Annotation processing. So we are all using annotations, right? They are everywhere. So what I'm going to tell you today is what happens under the covers when you put, for example, a transactional in a class, right? Who knows that? Yeah, OK. I will ask you a few questions. So basically, there is two things that we have to do. First of all, we need to discover the annotated classes, right? There has to be some mechanism in which someone will find that your class has a transactional in a method, for example, right? And when that's happened, we need to basically handle that logic. So in the case of transactional, you can imagine the logic is quite simple. So we need to wrap around the method invocation, if it's in a method, right? We need to wrap around that invocation with the transactional behavior, right? So open transaction, then delegate the method call, then commit or roll back the transaction. So far, so good. Yeah, blink your eyes if it's going well. So I will explain you all the techniques that can be used to do annotation processing at both runtime and compile time. So instead of runtime, let's talk about runtime discovery. We are still in the discovery phase. We have, for example, the case of a Spring. when you have a Spring application, Spring Boot application, Spring will iterate over the classes by default on a given package, right? Throughout this presentation, I've included these warning icons to highlight things that I think they're not so good to be done. So iterating over the classes means that there is some file I/O operations done on all the jars on your class path and the classes of your project. And using a custom class loader, they will load every single class into the class loader, and then use the reflection API to query some metadata of the class. Like, for example, give me all the annotations of this class. Give me all the methods of this class, and for each method, give me all the annotations of the methods, right? And it will visit every single class, and for every single class, it will visit every single field and every single method. And this will happen every single time you start your application, every single time. Is anyone using Spring AOT? Only one hand. That's really surprising, because this is, I'm by no means a Spring expert here, right? You probably know more than me. But it's my impression that Spring AOT is the direction they want to go with Spring Boot, right? So with Spring AOT, they are going to basically remove some of these runtime operations because they are expensive. I will explain you later why. Can we do differently? Are there any other options out there to do this? Yes, they are. Like, for example, we have a library. This is not a framework. It's a library, of course, right? There is a library, low-level library called ClassGraph. ClassGraph is used by some other libraries, like, for example, OpenRewrite. What this library is doing is, because iterating and scanning the class path is an expensive operation, right? So what you need to keep in mind that loading a class into the class loader will mean that you need to run, for example, all the static initializations of the class, right? There is a cost to do that. So to avoid that, ClassGraph will parse the binary format directly. They swallow the bytecode with a custom parser, right? And well, they have an API. Considering that this is happening at runtime, is quite fast and very highly optimized. There is another library in the Java ecosystem called Barring Wave Core, which is using a similar approach, right? So it's avoiding the cost of loading a class into the class loader. But we are all still at runtime. And that's all the options that we have at runtime, right? You either do class path scanning, which is the Spring approach, or use like a different library, right? Now, how do we implement the logic? Imagine, for example, that you have a transactional on an interface, right? One option could be dynamic proxies. Dynamic proxies are a built-in capability of the JDK that have been there forever. It is basically a Java API to implement classes at runtime, to implement implementations of an interface at runtime using a Java API, the proxy class API. To do so, the JDK will generate bytecode at runtime, and then it will load this new class that has been generated on the fly into the class loader so that you can use it, right? And the limitation of this built-in capability is that it only works for interfaces. For example, Spring Boot can be forced to use dynamic proxies. But as soon as you have annotations on a non-interface, it will throw an exception and will tell you that you need to disable that flag. It's obviously not enabled by default. There is a library very common called cglib. cglib is mostly used by Spring. It's very mature. And it's used to generate dynamic proxies, not only for interfaces, but for any other regular classes. But it can be used to also to dynamically, they call it dynamically enhance, and I read it as mutate, and that's problematic because you're going to be able to mutate existing classes. CGLib itself is no longer maintained, and they have a quote on the homepage saying that it's probably not going to work with newer JDKs, right? So the good news for you, Spring users, is that Spring has its own fork. They maintain it. It works for the use case of Spring, so you don't have to worry about that. CGLib and many other alternatives are using ASM, which is the foundation for everyone. Almost everyone is using ASM. ASM is a very low-level library for doing bytecode manipulation. So to use ASM is again a Java API, but you need to basically master the bytecode instruction set, right? You need to be aware of a load instruction or a jump instruction or whatever it is. There is an alternative called ByteBuddy. ByteBuddy is much more modern. It's used by Hibernate, Mockito, Jackson, Selenium, Spock, right? Basically, everyone else but Spring. ByteBuddy will allow you to generate or change classes. They have 3 modes of operation. There is a Java API, which is what I will show you in the demo. There is a Java agent that you can attach to your build, or they have built plugins for Maven and Gradle. It is fast, considering that this is happening at runtime. So remember, we are generating bytecode at runtime, right? The API is nice, and it's very well documented, and there are a lot of samples. And finally, we have a standard in the JDK called the class file API. So the class file API is essentially a standardization over ASM. It's literally a replacement of ASM. The OpenJDK itself will use bytecode generation for things like, for example, when you use a lambda, it will generate like an anonymous inner class bytecode for it, right? And to do so, it used to use ASM, but using ASM inside the JDK is problematic. So they basically came up with a standard API. But this is the same idea. Let me show you a little demo. And actually, I don't need to leave this. So what I have here is a demo of using ByteBuddy. Let's suppose we have this theoretical service that we have a do something method, and we have this timed annotation, right? We want to implement the logic for this annotation. The result of this annotation, you can guess, it will actually measure the time that it took to invoke this method. Yes? So far, so good? This annotation has a runtime retention policy, which means that when any class compiled with this annotation, when at runtime I use the reflection API to query the annotations about this class, the annotation will show up because it's going to be retained at runtime. And I'm explaining this because there are other retention policies. So that's the annotation, and then the method is basically printing a message, but with a random weight, so we get different execution times. And then the actual implementation in ByteBuddy. This is essentially the code needed to get a reference to an anonymous class that's going to be generated here, right? You tell it like, I want to subclass my service. I want to give it a name, main time service, and then plus this suffix. I want to intercept methods annotated with timed, and I want to delegate them to this time interceptor that I have here below. And then load the class into the class loader that I'm running on, and give me the loaded class. And then using reflection, I will make a new instance and then invoke the method. Yes, so far so good. The interceptor implementation is very easy. So you basically, this super object that you get here is the actual object that's going to be invoked. So you just need to measure the time at the beginning, delegate the call, and then measure the time at the end. Right? Yes, so far so good. So if we run this, then it's doing the job. We get the message, right? If I run this in debug mode, we can see that my time service variable is, the type is my class, but the actual instance is not, right? You see that? This happens all the time with Spring. Your objects are not just or objects. They are something else. They are proxies. Proxies of things that are not your actual classes, right? What's wrong with this? What's wrong with runtime annotation processing? Basically, class path scanning is slow because it takes I/O operations, right? Secondly, reflection API is slow. It's terribly slow. It's very CPU-bound operation. And because it is slow, what happens is that frameworks will have a reflective cache of this information, so that they don't have to query over and over again, give me the annotations of this class, give me the methods of this class, and the annotations of the methods, blah, blah, blah. So they will cache that in memory. But you guess what? You probably are not only using Spring Boot, but maybe also Hibernate. Anyone using Hibernate here? Yes? Hibernate is heavily based on reflection, right? The entity manager and the very likely the bins, the entities that you have, they are not your entities, they are proxies to something else, right? So that they have these persist operations logic, etc. And because Hibernate is heavily using reflection, Hibernate has its own reflective cache. It's different, right? So using reflection and using all of these techniques is not only going to cost time when you start your application, it's going to cost memory. And there is no limit, right? The more classes that you have in your project, the more dependencies that you have in your application, the more time it will take for the application to start, and the more memory it will consume. And like I said, there's no limit. And also remember, to implement this logic, they have to generate bytecode on the fly while your application is starting, every single time. And bytecode generation, as you can imagine, is expensive. Then after that, you need to load the class into the class loader. And finally, all these techniques will just make it harder to make a GraalVM native image work, right? So what's the alternative? The alternative is to do this during, let's say, the build phase, right? Build phase. Let me make a difference between the build phase and compilation phase. So build phase, I say build phase like what happens in Maven when you run Maven, for example, Maven verify. Anyone using Maven install frequently? Do not use Maven verify, unless you want to specifically install that into your local repository. But when you run Maven verify, that's the build phase. And compilation is one of the things that happen during the build, right? So in the case of Quarkus, Quarkus is using different libraries. They are all developed by them, basically, to avoid this runtime processing. The first library is Yandex. Yandex is a Java class file indexer that is used during build time, right? So it's done is a separate stage of the compilation, right? Yandex will essentially parse the bytecode, so it will run after the compilation phase of your project. It will parse the bytecode and will collect all the metadata into a persistent index, so that when your Quarkus application will run, it will load this index in memory, and then it has all the necessary information to query about, like, for example, annotations and methods and everything. They don't have to use the reflection API, right? Quarkus obviously also needs to generate bytecode, and they use a library called Gizmo. Gizmo is a library to generate new bytecode. The bytecode generation of Quarkus also happens during the build phase. It's not during the compilation phase, but it's during the build phase. It is written on top of ASM, and can also be used to mutate existing classes, right? Quarkus has two kind of entry points to allow you to do bytecode generation. This is only relevant if you are going to implement a Quarkus extension. But as a Quarkus user, you will rarely need to do this, right? One is the recorder. So recorders is a kind of a trick they have to basically allow you to implement the custom logic that you want in Java. So once that's compiled, they will get the bytecode, and they will inject it at runtime when necessary. And the other option is essentially using the Gizmo API directly, which is the example you have on the left. But it turns out that there was something there since the beginning, and nobody basically cared about using it. It's called Java Annotation Processing API. It was introduced with the JSR 269 in 2006. It's we probably have someone in the audience who wasn't born in 2006. So it was with Java 6, right? And it is basically compiler hooks for Java C. That's an annotation processor. It is used by frameworks like Micronaut, and there are other libraries like Lombok and Mapperstruct, which are also annotation processors. So, is anyone using Lombok here? Let me look at your faces, because I will look after you later. Not yet, not yet, not yet. So let me explain you what happens during compilation. Or actually, not yet. Let me tell you, annotation processing happens in different rounds, because during annotation processing, you can generate a new class, right? If this class has annotations, by generate a new class, I mean generate a new source file. If this source file has new annotations, then you need another round of compilation, right? During annotation processes, you only have sources available, so you don't have any dependencies of the class path of the application or anything like that, right? So the inputs are very limited. You can have different libraries, but the class path of the annotation processing is going to be different than the compilation class path. What can an annotation processor do? Like, for example, you can generate source code, which is the case of Mapperstruct and Micronaut. You can generate new bytecode, which is the case of Micronaut. You can modify existing classes, which is the case of Lombok. And you can do something else, like, for example, generate out of the annotations of a project, you can generate the Kubernetes descriptors. That's the case of Decorate, for example. Micronaut will generate OpenAPI specification from your code, etc. Right? So let me talk about Lombok, but first of all, can someone explain me why the hell we have signed here. This is like a neighborhood or something like that in Utrecht? My God. Okay. Yeah. Is anyone living literally in that neighborhood? Because I'm so sorry. What? No. Okay. Yeah, I can guess why. Why? So remind me again, who's using Lombok? Raise your hands, yes. Okay. Lombok is, I heard a quote by a friend who said that Lombok is like a cocaine, like at the beginning it feels great, but you can't get rid of it. So, but I'm here to heal you. So Java compilation is a very interesting process. There are 3 stages. First of all, we have the parsing stage. In the parsing stage, you will get, like, for example, if you have a syntax error, it will be detected here in this stage, right? So we essentially check syntax, that basically the text of your programs are compliant with the grammar, the language grammar. Yes? If that is OK, then we move into the annotation processing stage, which is basically within a loop. After the parsing stage, the Java compiler will build a set of ASTs, abstract syntax tree, which is a representation of your code. So we have a compilation unit, we have a class, method, statement, variable declaration. Follow me? Yeah? That's the AST of your program, and the AST is given to annotation processors, right? Annotation processors will essentially flag to the Java compiler which annotations they are interested in, and JavaC will call you. And then, as a result of annotation processing, if we are going to generate a new source file with annotations, then JavaC will detect that and will invoke a new round of compilation until there's no unclaimed source files to be processed. And finally, in the final stage, we generate bytecode. And also, it's when, for example, the Java compiler will do optimizations like custom folding, method inlining, etc. So our happy pepper. I want you to think about, like, for example, the @toString annotation. You put @toString in a class, and then magically a toString method appears, right? How the hell do you do that? Because the annotation processing API will not allow you to touch any class, right? So what they do is they mutate the AST of your classes. And to do so, because it's not an allowed operation, right? So to do so, they will use loopholes in the compiler, right? And they will do that for every single compiler on the market. So the loophole they use for hotspot is different than the one they use for OpenJ9, right? So they need to do this for every compiler on the market and for every Java release, right? So that they get access to the AST, and then once they get that, they will inject this new method declaration into the AST of your class, into the compilation unit of your class. It's not a happy pepper anymore. It's a sad pepper. There are many problems. If you search on the internet like Lombok problems, you will find a lot of content about functional problems that you will find using Lombok. Like, for example, if you use data with JPA, you will get much more and you use like schema generation, you will get more columns that you may need. That's a different story. So I'm here to tell you the technical problems and the moral problems, if you allow me, that using Lombok is going to give you. So first of all, these loopholes that I told you are going to be closed one by one. So this is mouse and cat race between the OpenJDK team and Lombok. For every new Java release, Lombok will have to see if their tricks are still working. If not, then you're in trouble because you can't upgrade your application until Lombok has a new release available for the new Java version, right? So Lombok is going to limit your ability to upgrade to future Java versions. It's going to mutate the AST, which means that it will break other annotation processors. So basically, Lombok needs to do their shit first, because if it's otherwise, like for example, you can run a Micronaut with Lombok, but if Lombok is run last in the annotation processing rounds, it will destroy what Micronaut created, and then your application will not work, right? So it needs to run first, and do all the mutations, and then the Micronaut annotation processor later. This AST manipulation will break incremental compilation, which is something that you're only going to enjoy if you're using Gradle. Anyone using Gradle here? Yes, but that's a feature that you have in Gradle, incremental compilation, and incremental annotation processing as well. And the larger question that I asked you is, do we need it anyway? Like, I get the point of using Lombok with Java 8. The language was not what it is today. So I want you to think about whether you need it anymore, right? So we have modern building blocks built into the language today. So perhaps it's time to get rid of this cocaine and be better about it. So if there is a single advice that I dare to offer you today, is to reduce the number of dependencies that you use on your application. So how do we do it at Micronaut? Anyone never heard about Micronaut before? Right? So basically, there's 3 ideas I would like you to get about Micronaut. First of all is that Micronaut is an open source Java framework. And it's a modern framework created recently with the type of applications that we create today. It's a general purpose framework. You can use it for any application type. People typically use it for REST APIs, but you can have command line applications, serverless functions, or I don't know, like for example, a Kafka consumer that doesn't have any HTTP server whatsoever. The third idea is performance. For us, performance is an obsession. We work really hard to shave every millisecond that we can from the application startup and every megabyte from the memory consumption. Because we believe, and there is a point in this belief, that those 2 particular metrics, which are startup time and memory consumption, will dramatically change your developer experience. The technique we use to do all of this is, generally speaking, this is called AOT, which is called ahead of time compilation. This is as opposed to just in time, right? So ahead of time, we will compute all the framework infrastructure. So that at runtime, there's no reflection, there's no proxy generation, no dynamic class loading, and we don't scan your class path. Most of the times, we are going to be generating source code, bytecode directly, but there are some cases where we're going to be generating source code as well. So Micronaut is essentially a smart compiler platform, or whatever you want to call it, because it's built in on top of the Annotation Processing API. We support multiple languages. And at Micronaut, we believe that the framework should come batteries included. Because of the advice that I gave you before, we want you to use less dependencies, right? In red, things you don't need anymore. Like for example, or actually, what you don't need anymore is the ones in blue. So we have in introspection, which is a replacement for the JDK interpreter, but it's reflection-free. We have built-in beam validation as a replacement for Hibernate validator, but our beam validation is 10 times faster and 10% memory consumption. We have built-in beam mappers as a replacement or an alternative to MapStruct. MapStruct is a wonderful library, and it's also a good citizen in the Java ecosystem because it's doing things right. But it's a whole library for doing beam mapping. From the simplest use cases, Micronaut built-in beam mappers will be enough. Whereas we have Micronaut serialization, which is a drop-in replacement for Jackson data event. Jackson is also heavily based on reflection everywhere and will contribute to your application startup time and memory consumption. And Micronaut data JDBC with compile time checks, so you get compile time errors if you have typos in your repository queries, as opposed to a random exception. We do compile time checks everywhere. And it's an alternative to Hibernate. And this is all compatible with GraalVM native image since day one. So like I tell you, our hope, our goal is to help you reduce the number of dependencies. I have a little demo of, it's the same demo, but in this case using Micronaut. So Micronaut AOP is an AOP, let's say, framework built inside Micronaut. We use it internally, obviously, for things like, for example, the declarative HTTP client, but you can use it yourself as well. And it's compile time, reflection-free, etc. So in this case, we have my time service is going to be the same. The time annotation is going to have a source retention policy. We don't need this annotation at runtime because we're not going to query it, right? It's maybe it's a very little difference, but this is less bytes in the jar files for every class, right? So less things that we don't need. And then the interceptor logic is very similar. So we have like a method interceptor interface that we implement, and then we measure the time, delegate the call, and then measure the time again. The main class, we run the Micronaut application, we get the service from the application context, we invoke it, right? So I can run this, and if the demo codes are with me, it's gonna work, yes. If I run this in the back mode, not this breakpoint, sorry. This service is again a proxy, but this proxy, it is here. Right? This was generated during compilation, as opposed to the one from ByteBuddy, which doesn't exist anywhere. So basically, if your source code is not going to change, this bytecode will basically remain unchanged, right? We have a source gen module with the idea of being like a platform for doing source generation for different languages, namely Java and Kotlin. We're shipping with a few annotations to like a gateway drag to switch, to allow you to switch from the cocaine Lombok to something more lightweight. Our promise is that we will never mutate your classes. It is our promise. So why startup time and memory consumption is relevant? If I run, run a service in production, it's running all the time. So okay, when I run it, it's going to be slow, but it's running all the time. So why is this relevant? First of all, because yes, in production you run it maybe not that frequently, but during development is when it matters, right? If you have something that can start up in milliseconds, then you can run functional end-to-end tests in milliseconds. And that's the case of Micronaut. You don't need Mockito, you don't need mockMVC, you don't need any of that, because you can simply run your entire application within milliseconds. During development mode, hot reloading is not even needed, because we simply kill the process and start it again. The other answer to this is, for example, in cloud-native deployment. So when you deploy to Kubernetes or to serverless, for example, in the case of Kubernetes, if you have pods that can come up instantly, then you can almost scale to 0, right? Or basically, you can reduce your cost, right? You can get HA with less money. And in serverless, it's obviously important, because in serverless, the less time your function is going to take, the less money you're going to pay. And if you want to squeeze this performance even more, you can use GraalVM native image, where Micronaut is the best framework that supports GraalVM. And I'd like to finish this section with the use case of Disney Plus, which is Disney Plus has one microservice, is a messaging microservices internally across the rest of the microservices, and they deploy that on AWS Lambda, and they realize that using Micronaut and GraalVM will save them a ton of money. So I recommend you to read the use case. So that's all that I have today. So did you learn something new? Yes? Did you have fun? Thank you very much.